All right. Hello, my name is Derek Jenkins, and I'm presenting this paper called Stack Overflow Considered Harmful: The Impact of Copy and Paste on Android Application Security by F. Fisher et al. At the 2017 IEEE Symposium on Security and Privacy. So let's first look into what Stack Overflow is. Stack Overflow is a public discussion platform where developers can post questions and other developers can provide answers to those questions. And oftentimes they'll post snippets of code as examples. Um, and a lot of times if I, provided an answer in a code snippet, then it'll be very helpful to just copy and paste that into my own production code if it works. So, I mean, this enhances efficiency and it allows promotion of best practices because those answers will be given by, oftentimes more experienced developers that know what they're doing. But there are many cases, especially in the case of Android related code snippets. So for Android application software, and a lot of these code snippets actually disregard security. So there are cases where they request too many unneeded permissions or they fail to properly validate certificates. And many times they'll misuse standard cryptographic APIs. Um, but, if I'm a developer trying to get something that works, uh, these code snippets will provide functional code. So if I'm, not concerned about security, then this it doesn't really provide any problems, right? So these insecure code snippets will end up making their way into production code. For example, on the right here, we have a function that's to verify a host name with a certificate. However, this function always returns true, and it's perfectly, uh, functional code. But the problem is that it doesn't actually enforce any type of security. It just lets anyone through. So um, this is the problem that the authors are trying to find is how often is this the case where code snippets like this are making their way into production code in the Google Play Store and Android apps in general. So is Stack Overflow harmful in this case? All right, so the authors provided several contributions with this paper. And one of them was they're identifying security-related Android posts on Stack Overflow. So they're creating a systematic way of uh, crawling through Stack Overflow's database and selecting posts based on certain attributes. Um, They also were looking at free apps on the Google Play Store and were providing a way of systematically analyzing these applications as and trying to figure out, okay, how much of this code base is actually copy and pasted from snippets on Stack Overflow. And we'll get to how they make that connection later on in this presentation. Um, and then they also figured out a way to, okay, if we're using a code snippet from Stack Overflow, how do we decide is it secure? Is it insecure? So here's a high level overview of the pipeline that they used to do this processing. So going from the left to the right, they pull all the code um, snippets from Stack Overflow and they applied some filtering techniques to just pull out the security related posts and code snippets. Then from this point, they classify them as secure or insecure, and then they transform that data into a type of program dependency graph because code as plain text isn't really comparable to code that's compiled that you'll get from Android apps off the Google Play Store. So we'll get into a way that they're able to make that connection of plain text to bytecode and how they're able to make that comparison and identify oh, this app is actually using a copy and pasted snippet from this post. All right, so we're starting from the left side of the processing pipeline. So this is just the code extraction and filtering. So first, we need to be able to identify security-related code snippets on Stack Overflow. And the authors define this as just specific calls to APIs in the code snippets. So this could be APIs related to cryptography, secure network communications, public key infrastructure, and then authentication and access control. And they also included some other third-party libraries that are shown to the right. Um, and these are applicable with regards to some of the security systems that we see at the top. So any code snippet that includes calls to APIs regarding these libraries and this general functionality, these are considered security related code. Now, now that we have security related code, now we need to break that up into what is secure and what is insecure. So secure code, the authors defined, is just using up-to-date and strong algorithms, sufficiently large keys for uh, RSA, elliptic curve cryptography, and secure random number generation, and just any other code snippets that don't have explicit vulnerabilities in them. So it could be, something that just doesn't have that exploitable weakness. So we're just going to consider that secure code. It's not exploitable. Now, insecure code, these are code snippets that use outdated algorithms, static initialization vectors, weak keys for symmetric and asymmetric cryptography algorithms, insecure random number generation, insecure TLS implementations. And the authors acknowledge that this isn't a comprehensive list of what is insecure, right? There's many other ways that code can be insecure, but they had to have a formal definition somehow. So this is what the authors used. All right. So now we need to figure out a way to automatically classify this data. And the authors decided to use a machine learning algorithm known as support vector machines. So they first went in and manually labeled, um, several hundred up to 1,000 of these code snippets as either secure or insecure. And then they were able to train a SVM machine learning model to discriminate between these. And we'll get into how we're able to represent these code snippets in a way that the SVM can uh, interpret them. Um, so we treat this problem as a document classification. So these code snippets are in plain text. So what we have to do is break up the text into a series of tokens, and then we apply scores to these tokens using TF-IDF, which is term frequency inverse document frequency. So certain terms that you might see, in a code snippet, if it occurs very frequently, it's going to get a high score in the TF component. But if that token appears in many different documents or many different code snippets, and that's going to lower its score. So we're able to get a sort of a normalized value across all the tokens, across all the code snippets. So each snippet is going to get assigned a score vector, and this is what is used as a sort of transformation from the plain text. All right, so now we're going to get into the code detection piece. So now that now that we've defined the transformation for the plain code, now we have to actually create a program dependency graph because this is how we're going to be able to compare the code to the compiled bytecode in the Android applications. So uh, this way we have, an apples to apples comparison The authors use this tool, WALA, WALA, which is used for static code analysis on compiled byte code. So this creates a a program dependency graph, and the authors are also going to be able to compare that to the original byte code or the original source code in the code snippets. All right, so now that we've defined that entire pipeline of gathering code all the way to seeing if these code snippets are indeed in the Android applications, now the authors actually went through with the implementation. So first they gathered code snippets from Stack Overflow. They downloaded the entire database of Stack Overflow posts, which was, 29.5 million posts in total. They filtered that down to just under 2 million Android related posts. And of those, there were about 4,000 security related Android posts. And then here's a listing of, okay, these are security related, but how are they security related? Well, they use calls to these public APIs. And so just to point out the top um, library that was used in these security related Android posts was this java.security, and uh, I believe that was more for TLS applications. So just quickly going through how the classifier for machine learning is working here. So on the left side here, this is a running evaluation on the secure and insecure posts. So the axes on this graph are sort of abstract. This is just a projection of the high dimensional feature space into two dimensions using principal component analysis. But we can see on the left side here, almost all the insecure posts are going to be to the left of this discriminating solid line, and then all the secure are going to be to the right of it. And there is some overlap and crossing the boundaries here. So it's not a perfect model, but it's in general sufficient enough to be able to classify between these two classes. And then these are just accuracy, precision, and recall scores as we vary the training sizes. Um, so as we train on more and more data, we generally see a trend of better accuracy. All right, so the authors then gathered all the free Android apps that they could, which was over 1.3 million apps. And then they kept on, you know, they held on to these apps and making sure they were updated, up until May 2016. And then going through this whole classification process, they identified that just under 200,000 of these apps contained code snippets that were copied from Stack Overflow, and that these code snippets had insecure code. So that is quite a staggering number. So looking at this, what are some of the biggest contributors to this? The biggest one was for a TLS library or TLS application. So 180,000 apps we're using this empty trust manager, which is used to verify a certificate with a host name. But this Stack Overflow post or this code snippet actually just gives an empty trust manager saying, hey, just accept this certificate with this host name. And this basically just disables server verification, which, just completely bypasses the whole concept of TLS. So this basically makes, the apps vulnerable to man-in-the-middle attacks. Another another one of these, common insecure snippets. Oops, let me go back. Is for symmetric cryptography applications. So 18,000 apps used AES in ECB mode. Now the problem with ECB mode is we can see on the right where it'll, um, it basically uh, you know, hashes this picture here, but it keeps the same structure. So same values on the input are going to be mapped to the same values on the output. So this is vulnerable to chosen plain text attacks where we can figure out the algorithm's keys based on knowing what the plain text is. So this is a big problem. So I guess the question is Stack Overflow harmful? Well, on Stack Overflow, there are many secure and insecure code snippets. Um, and there is a feedback system where people can comment on each other's posts. But it seems like it's not sufficient when it comes to making sure that the posts are safe and helpful with regards to security. Because people can simply just overlook warning posts. If I go in as a commenter and say, "Hey, this post is insecure," well, first of all, it might already be in production code. So, it doesn't really help in that regard. And also people might just ignore my comment in general. So the authors acknowledge that, yeah, there's definitely some future work involved here. So we can definitely make some improvements to Stack Overflow. And one example of this is, maybe we can work on a security related interface that provides real-time classification. Like as you're looking through the post, it'll flag certain code snippets as, hey, this is insecure, use at your own risk. um, just to provide some sort of visual security indicators for the users, uh, so they don't just copy and paste code willy-nilly. All right, so that is the end of my presentation, and thanks for watching.